Welcome everyone to Coordinate Systems in FME 101. Today I'm joined by both Evie and Dan as our speakers. I'll pass it over to Evie to introduce herself.
Yeah, I am Evie and I am on the technical support team for Safe Software. I focus on FME form and yeah, I'll pass it on to Dan.
Hey, my name's Dan. I'm a customer solutions specialist at Safe Software, so I focus on helping our customers get the most out of the FME platform, and I've been with Safe for just over 3 years now.
Awesome. Thank you both. And we also have Dave, seasoned expert and pro on the back end. So if you have any questions throughout the webinar, please do leave those in the questions tab and Dave will help us get to those. And then we'll also have live Q&A at the end as well. So we can discuss anything further or get to any that we haven't gotten to yet. Yeah, as I just mentioned, under the questions tab, please leave any questions there throughout. Keep letting us know where you're tuning in from in the chat. We have 2 polls coming up today, so keep an eye on the polls tab for those. Share your emoji reactions with us during the webinar with that react button in the middle. And then if you do have any audio or video issues during the webinar, click that help button for 4 simple steps, the first one of which just being to refresh your browser. All right, and with that, I will go through our agenda here. But before I do, I will have our presenters turn off their webcams just so we can save on some bandwidth for the rest of the webinar. Today, Dan and Evie are going to provide us with a parameters tour across the whole FME platform. So beginning with a high-level overview of coordinate system, projections, and datums, and then they'll dive more into how FME works with coordinate systems and different reproduction engines used. From there, they'll share with you our own parameter best practices and summarize key points on how you can take away these notes and these tips and tricks from today's presentation to apply to your own practices. And then at the end, we'll also provide you with some resources to help you get started with your own coordinate systems. We'll open things up at the end for that Q&A period. All right, from here, I will pass things over to Dan.
Awesome. Thanks, Elizabeth. Yeah, we're going to be focusing in on coordinate systems today, but we're also going to be talking a little bit about how FME works with coordinate systems. So we just want to give you a quick introduction of what FME is in case you're not familiar. I'm sure lots of you here have worked with FME before or are current users of FME. But yeah, if you're not familiar, we've got our 2 products here. So we've got FME Form, which is our data movement and transformation products. FME in general is an enterprise integration platform. So FME Form sits on the client side, it's where you build out your workflows. And then FME Flow is where you bring those FME Form workflows to life by automating them. And that can be deployed on your premise or in private cloud or through FME Flow. So yeah, this gives you a quick overview. A lot of what we'll be talking about today, we'll be focusing in on where you're authoring your workspaces, adding in readers and writers, and reprojecting through FME Form workspaces. Yeah, that's what we'll be talking about today. And if you've ever worked with or wondered what coordinate systems are, then you've probably touched them before looking at a map or working with GPS data. And if any of you are familiar with smartwatches and use it to track walks or runs or any sport really, then that information needs to be correlated to a map using a coordinate system. But not everyone knows why we have coordinate systems or what they're used for, or how we can use them to maximize the value of their data. And sometimes you might have data sets which are in different coordinate systems and you're not using them right now. You'll want to reproject those to get those into the coordinate systems that are usable for your organization. So to start things off, we wanted to do a quick poll on what is your experience working with spatial data? And more specifically, have you worked with coordinate systems at all? So if you take a look in the bottom right there where it says polls right next to the chat box, you'll be able to open that up. And you can submit your vote for that.
Perfect. Okay, it looks like the majority have already voted. Thank you, everyone. And it's looking like the main results are either about split, actually, about 44%. I work with these quite often, and then another 44%, so completely tied. I work with these every day, which just took the lead. And then we also have another 13 or 15% or so that have little experience working with these and haven't had any experience working with these. So definitely a learning opportunity.
Yeah, great wide crowd here today, which is good. And I think even those that are familiar with coordinate systems will still get a lot out of this webinar for sure. All right. So when we're talking about coordinate systems, there's a couple of basics here. We've got our projections and our datums. So when we're talking about a projection, when we think about maps and how we view those maps, we're looking at those on a flat 2D surface, whether that's a physical or a digital map. But the Earth is not flat like a map, it's a three-dimensional surface. So when we try to map coordinates or locations that were obtained, for example, by satellites, those coordinates need to be projected onto a 2D plane. One of the metaphors for this is thinking about wrapping a piece of paper around a globe. You're going to have creases and folds in that piece of paper because you know that it's not fitting perfectly over the globe. So that's something we need to keep in mind when we're reprojecting our data. So in FME and just in general in the GIS world, all of this reprojection is done through mathematical algorithms. This is handled by the software we use, and FME is no exception there. And yeah, exactly. We won't worry too much about the algorithms here, since that's what the coordinate systems are for, and the projections do for us. And once we projected our data, things are measured in linear units. So you can think of that as feet, meters, or any other linear units. Whereas those original measurements would have been in latitude or longitude. So one of the more familiar projections in the GIS world is the Mercator projection. So it's a conformal cylindrical map projection, and preserves local directions and shapes with north is up and south is down. As you can see in the image on the right, the further you get to the poles, the further apart the latitude lines are. As you get closer to the equator, you have more accurate projections, and as you get further away, it's less accurate. The typical example of this is that in this image on the right, you've got Greenland at the top there, right above Canada. And it's essentially the same size as Africa in this image, but we all know that's not quite true when it comes to looking at the Earth on a globe. And this is one of the most common projections used for web mapping. That's typically due to the fact that direction is preserved. And for example, Google Maps has been one of the main proponents of the Web Mercator projection. We've also got the transverse Mercator. So this is just a variation of the Mercator projection, which is great for north-south mapping. So it's essentially just that cylindrical conformal projection turned on its side. So as opposed to having your accuracy at the equator, you've got your accuracy at the poles. So distortions are going to increase east and west of the central meridian. And again, this really just shows how a projection can affect the accuracy of certain areas and explains why there's so many projections and why FME has support for over 5,000 coordinate systems. Next, we got the Lambert conformal. This is more accurate for mid-latitudes and has an east-west dominant projection and preserves shape very well. As you can see with all these worldwide coordinate systems, none of them really work at projecting information across the whole globe in a 2D fashion. Each have their own advantages and disadvantages based on what you need to use them for. So that's just something to keep in mind when you're deciding on which coordinate systems you want to use. The last one we'll talk about here is the Lambert azimuthal equal area. So this is a very low distortion projection around the local area of origin. So this can be used anywhere in the world and is considered what we call an equal area map projection. So scale and directions are true only at the center of this projection. And the shapes, directions, angles, and distances are generally a bit distorted as you move away from that origin. But the main thing here is that the area is the most accurate with this one. And when talking about the Lambert-Azimuthal equal area, that kind of leads us into our next topic here, which is local coordinate systems. So you can imagine you could take that Lambert-Azimuthal equal area and move that to any local area that you wanted to have a projection around. This is what we refer to as a local coordinate system and is commonly used for across BIM, CAD, 3D data sets, anything that deals with a small area. Could even be a GIS data set for construction sites or an airport or even a city. And by having that local origin point, we're using this azimuthal equal area coordinate system and having a low distortion of area around that point. So I'm sure many of you are familiar with state planar coordinate systems. There's also the UTM coordinate systems and various other ones. So let's talk about datums a little bit and datums in GIS. So when we're talking about a datum, it's a model of the Earth, what we call an ellipsoid, that is tied to a particular spot on the Earth. So because it's tied to that particular spot, we need to have different datums depending on where in the world we're actually mapping our data. So for example, we have NAD 83, which is for North America, North American datum. But then we also have GDA 2020, which is the geocentric datum of Australia. So you can see if we were to use our NAD datum for mapping features in Australia, then the accuracy would probably be off a little bit. So, and as changes come with the Earth and new datums are produced as well. So when we're reprojecting data, this often requires transforming between datums. And there's two types of datum transformations here. We have mathematical transformations. So there's a couple of simple ones, 3-parameter and 4-parameter. 3-parameter is going to be defining the translation difference between the origins of the ellipsoids used for each datum, whereas the 7-parameter is going to be defining the translation, the rotation, and the scale change between the origins and the axis of the ellipsoids used for each datum. And then we also have adjustment grids. So these are typically accompanied by a grid shift file. And a couple of different ones here. We have NADCON V2. So that's developed by Natural Resources Canada and used widely across North America by other countries and generally across the globe as well. FME does support grid shift as well, and you can also implement your own grid shift files if you need to. And when we're talking about datum transformations, one thing to keep in mind here is plate tectonics has a big play in things. You might not think that plate tectonics have too much of an effect on the Earth and what we measure on the Earth, but just over the last 25 years, Australia has had a 2-meter shift in the continent and the continental plate. That's why they've moved from one of their old coordinate systems to the new one released in 2020, which is GDA 2020. And again, when we're talking about units, typically when we're with projected coordinate systems, they're in meters or feet, depending on the coordinate system used. So these are linear units. And with geographic coordinate systems, these are typically in angular units, so degrees or radians. Or in software such as FME, you might see these in decimal degrees since it's easier to display than fractions. So it's important to know your coordinate system that you're using. So for example, in FME, when you read in your data, you want to know what coordinate system it's in, because if you're going to be performing spatial analysis, this has an effect on how the analysis is calculated. So say you want to calculate distance between 2 points or the shortest path, then you'll want to know what your coordinate systems are and make sure that they're across your different data sets, that they're synced up as well. So coordinate systems in FME. We've been talking a little bit about coordinate systems in general, and I've hinted a bit at what FME can do, but now we're going to take a deeper look into how FME deals with coordinate systems itself. So one of the main things that we have in FME is an implicit reprojection. So we try to keep the simplicity of doing the reprojection in FME And in your readers and on your writers, we have what's called an implicit reprojection. When you say you've read in your data and you have your coordinate system set, or you don't have your coordinate system set, then FME will handle that automatically. I guess an example of this would be, say you read in your data, it's in UTM 83, and you want to write that out to a geodatabase. Say this is a new feature class that you want to write it out to, and you haven't specified your coordinate system. As you can see in the image there, it says coordinate system not set. Well, FME will automatically set the coordinate system when you're writing out your data, even if you haven't explicitly reprojected it or explicitly set it in the writer. So something just to keep in mind, if you haven't touched the coordinate system parameters on your readers or writers, FME will be handling that automatically. And with the implicit reprojection, you'll be able to get a view of your data and see what the coordinate system is as you work through your workspace. After FME's automatically detected the coordinate system, you can go into the visual preview and open up the feature information window. And in there, you'll get information about your geometry, including the coordinate system that it's automatically being assigned. And if you notice in here that the coordinate system isn't what you want, then you can just go back to your reader, and on that parameter there where it says coordinate system, you can just set that and ensure that it's reading in the right coordinate system. Most of the time I found it to be pretty accurate when you're reading your data, so something I wouldn't worry too much about. I'd just be a little more cautious about when you're writing out your data, and if you're writing out to a coordinate system, or you say you're writing out to an existing data set and you've been automatically assigned a coordinate system, FME will automatically reproject that for you when it reaches your writer. So again, use your source coordinate system parameter with caution. And the only reason we say that is because FME does a great job at automatically assigning the coordinate system. And you might even have, in another scenario, you might have coordinate systems that don't, or data that doesn't have coordinate systems, or formats that don't have coordinate systems, even though that data might. So say you have a CSV file that has a set of a Latin long, FME will automatically create geometry on that for you. It'll create point geometry, but you'll still need to set your coordinate system. So that's one of those cases where you would want to set it on the reader. Or if you want to, you can just work with your reprojector transformer and add that to the workspace. And it's a little more visual, a little more obvious where you're doing that reprojection, as opposed to being hidden in the reader and writer parameters. So in general, we recommend that you shouldn't set this parameter unless you need to, or unless you know that FME is not picking up the coordinate system correctly. But in general, it's up to you if you want to do it, but so that's our recommendation. So I'll pass it off to Evie to talk a little bit more about the different reprojection engines in FME.
Thanks, Dan. Yeah, so in FME, we have a couple different reprojection engines. We have CSMAP, Esri, Proj. This gives users more control over their transformations. What if you need to match application transformations? So we provide a choice of reprojection engines for all of your needs. So we'll go over all of the different ones that we have here. So in the reprojector, while implicit is the easiest reprojection, it always happens right before writing, as we said before. So sometimes you want to reproject within the workspace. So this gives you that option. In FME, you can add multiple readers and process them together, but FME doesn't automatically reproject these two data sets to the same coordinate system. So if you want to make sure that they are the same, it is good to have it in the workspace. So if they are different coordinate systems, this can cause problems when the geometries interact with each other, such as geoprocessing, like a point on polygon overlays, clipping, etc. Note that this reprojection engine used in the reprojector is CSMAP. And to move on to the CSMAP reprojector, you notice that we have a couple different options for transformations. This, if it's not changed, it will use default transformation, which can differ between a couple different FME versions. Direct transformations are favored over pivots. Setting both source and destination coordinate systems will populate the transformation dropdown with all of the available transformations. The key difference here, setting source coordinate system will override the feature coordinate system that's already set, which is the opposite of the reprojector behavior. And it can also do vertical adjustments in this transformer using height grids. This can be part of the reprojection or a separate adjustment by setting the source and destination coordinate system to be the same. So a little bit about the engine here is it is the easiest coordinate system support in FME to use because it is simple for the casual user. It has a large number of predefined coordinate systems that you can choose from a list. And the datum transformations were done by pivoting through WGS84 in a two-step transformation. So every datum just needs to have WGS84, and you'll be able to transform between the two datums. And it has a library of direct grid transformations as well. Moving on to the Esri reprojector. If you are an ArcGIS user, you may want to use this instead. You might prefer this. This uses Esri's reprojection engine and libraries, including coordinate system and transformation definitions. This gives you all of that option there. We also have Proj. So the Proj reprojector is another popular reprojection engine. For automatic transformations, just choose the destination coordinate system. For more control, you can pick the source as well. You can use EPSG numbers instead of choosing from a list. The reprojector will select an appropriate transformation between the two datums. You can also use manual transformations, but it requires you to supply the proj string for the transformation. This gives you the most control, but requires you to learn the string format. The proj reprojector has a more up-to-date coordinate system library than CSMap, and it can also use online transformation grids. We also have national reprojectors. So some national agencies have created their own regional reprojection engines. These are limited in their range and number of coordinate systems, but we support the following ones here. So GTrans is used in Sweden, Grid in Quest 2 is used in the UK, and Reframe is used in Switzerland. Some of our reprojection engines can also reproject attributes as well. These are the same as the regular reprojectors, but have the options to choose X and Y attributes instead. So this is useful for those needs. There's also local coordinate system support. So these are useful when using like 3D data, such as like BIM with 32-bit coordinates, which loses precision with larger numbers like those in most coordinate systems. They are also good for measuring length and area of lat-long data. However, we do not recommend Web Mercator for this. Calculated coordinate systems, or you can have the origin set by the user. We have special coordinate systems that will create a custom coordinate system centered on the feature or nearest lat-long grid. And the grid is best for many features. It cuts down on memory usage. The common local reprojector is great if you want all of your features to use the same local coordinate system. Source features must have the same coordinate system, and it finds the bounding box to determine this. The local coordinate system setter is great if you want to control the local coordinate system origin and the units. So moving on to another poll, what reprojection engine do you use most? You can find this in the polls tab down below.
Yeah, I've just launched it there now. So if people want to head over, it'll be interesting to see. Give everyone a moment to vote here. Any guesses as to what might be the top reprojection engine? Dan or Evie, is there one you might expect to be the most popular?
I'm thinking probably Proj or maybe Esri. We have lots of Esri users. Let's see. Oh, wow. Yeah, okay.
Yeah, most people have
A lot of
voted now.
Esris.
So.
Yeah.
Lots of
61%.
Esri users.
Yeah, not a surprise there. I think for a lot of people who are using, who have an Esri setup, they like to stick with the Esri reprojection engine for a good reason. So, yeah, it's always interesting to see the different ones that people are using. Proj is pretty high up there too, as well.
Yeah, and a handful of people too that haven't used one yet. Awesome. Thanks everyone for voting.
Thanks, yeah. So moving on to our next section here, we have custom coordinate systems. And to go over that, all three named reprojectors support custom coordinate systems. The Esri reprojector can use coordinate systems and transformations created in ArcGIS. The Proj reprojector has the manual mode to define with the Proj strings or WKT. NCS Map is the most complex, but we do have an online tool to make it easier for you to define these coordinate systems. We have the link there, and I'll demo it for you as well. So in the demo, we're going to use the web app online tool. We're going to download the coordinate system and place the coordinate system with all of our files for FME. So we'll just start the demo. So here we have the online tool. We're going to search for something that's similar to what we want, which is this one that I'm selecting. We can put the WKT if we want as well. I'm going to click submit. And then we just fill out this form here. So all of the name that you want to populate in FME, the number for the EPSG, the description, source, group, all of that. You want to make sure that all of the parameters are set correctly as well, like the quadrant, and I'll scroll down as well and show you the rest of them. And so you can also put in your WKT for Esri. And here are some of the other parameters. So you want to make sure that those are all good. And they look good to me for this projection and coordinate system. So I'm going to click submit. And then we can download your coordinate system definition and make sure that it's downloaded, and then put it in the documents FME folder. So I'm just going to go into it, extract it. And then I'm going to copy the files and then go to the documents folder, FME. And I'm just going to paste it directly into the folder, and it will paste them there. And there they are, all good. And I'll show you in FME as well what it looks like when you search for it. So in FME here, if you go to Tools, Browse Coordinate Systems, if you search in the number or the group or the datum, it'll show up there for you. Yeah, thanks. So moving on to the conclusion, I'll pass it on to Dan again.
Yeah, great. Thanks, Evie. So one thing we want to bring up was the future of coordinate systems. As new coordinate systems come out, there are questions around, do you support those? Are they going to be available in FME? And just in general, what's changing with coordinate systems? So one of the main things here is we have a few outdated datums. So of course, the GDA was updated in 2020, but NAD 83 is going to be replaced with a modernized national spatial reference system. So Because FME uses third-party reprojection engines for its coordinate systems, these changes are dependent on them. So we'll continue to support existing coordinate systems and new coordinate systems, and whoever adds them first will depend on the reprojection engines themselves. So typically we like to say that Proj will see the new coordinate systems and datums first. And one of the main reasons we say that is because Proj is going to be pulling in those coordinate systems from online, whereas Esri and CSMAP, those will need to be made available through updates to FME. Proj is independent of FME updates, which is really useful if you need to use new coordinate systems. Yeah, just to summarize again, Proj has the most up-to-date libraries. If you are looking for new coordinate systems or just a wider variety of coordinate systems, then Proj might be the right place to look if you can't find the right coordinate system that you're looking for. CSMAP is obviously the most customizable, as Evie just showed, where you can use your own custom coordinate systems and really just choose the reprojection engine and a transformer that suits your needs best. Any of the coordinate systems or reprojection engines really work well. It's more of a preference thing for some people, or it might be a requirement based on which coordinate systems are available through each reprojection engine.
Yeah, so there are some resources here I'll paste in the chat for us. So these are some documentation and articles related to coordinate systems. And I'll pass it on to Elizabeth to finish up.
Perfect. Thanks, Evie. All right. So we'll take us through these other free resources that we offer at Safe for All About Free Resources. So our first of which is our ebook, Spatial Data for the Enterprise, is a free ebook, as well as our FME Academy and Knowledge Base, which are great places to get guided learning at your fingertips. And also our Knowledge Base is home to a lot of how-tos and demos. And then lastly, I'll highlight our webinars. So we have a lot of upcoming webinars as well as hundreds on demand. So you can search by whatever topic you might be interested to learn more about, safe.com/webinars. In terms of next steps, if there's anything you'd like to chat with us about data, please get in touch, info@safe.com. And if you're newer to FME, definitely check out our FME Accelerator course. It's 90 minutes free of charge, and it's a great place to get started learning the basics. As a thank you for joining us today, we have a community badge code for any members of our community. I am just pasting that into the chat now as well. So just to redeem that on the community, just scroll down a little bit and there'll be a space on the right side of the page. If you aren't yet a member of our community, definitely check it out. It's a great place to both network with other users alike and also get in touch with experts to get any solutions to the challenges you might be having. All right, and with that, I will invite our presenters and Dave onto the stage here, and we can take a look at our questions panel together. Did see a good handful of questions come in.
Yeah, we have a lot of good questions.
Any that we might want to get started on, or Dave, did you see any that stood out that we might want to highlight today?
A lot of them have been very specific.
Okay.
I've been spending a lot of time chasing down Google entries and stuff. One of the more interesting one was for many of you who use state plane that the US survey foot has finally been retired. Yay! And it's all international foot. We have coordinate system definitions for state planes, also mostly an international foot as well. Just have to look for the IF suffix. There is a new datum coming out for US. So look for, it supersedes the various flavors of Net 83, I believe. So there is going to be a whole ton of new coordinate systems definitions coming in that people will be needing. I would say look to the Proj projector to have the most up-to-date ones over CSMAP. map does tend to lag a little bit on their definitions. But or if you want, you can define your own for CS map through that web page. But I think Proj is probably the more, like I said, up-to-date and useful one at the moment.
Yeah, and I just threw a link into the chat there if anyone's interested to learn more about the new datums coming out from the National Geodetic Survey. It's pretty interesting stuff that's happening. Some big changes there.
Okay, what are the questions? Oh, from David Eagle here. The FME community could do an article that covers core differences between the different reprojector transformers. Yeah, that's true. That's actually on my plate to write that. So I will work on that.
Love it.
Let's read through a couple of these ones. Yeah, there was one from Chris Brown about the British wartime Cassini grids, which I don't know, Dave, if you're familiar with those, but
no, but
I think in that case
now.
Pardon?
I'm frantically Googling now. That's one thing I find about coordinate systems and working about coordinate systems is, and that's part of the fun of working with coordinate systems, is yeah, sometimes there's a lot of searching for information, not necessarily there like what coordinate systems to use or what the origins of the coordinate systems are or what the parameters are, etc. I find that actually the most fascinating part about working with coordinate systems. Some of you may differ, right? But yeah.
It's always a bit of a challenge, isn't it? But it's a fun challenge.
Yeah, it is really cool when you find something wrong and you actually get to file a bug report with the EPSG. You feel really proud of yourself.
Yeah, so for that one, I think I was just saying a Proj 4 string or a custom coordinate system might work best there. I can see in the Proj reprojector, there's a couple of Cassini coordinate systems, but I'm not familiar with them, so it could be completely the wrong thing in this case.
Yeah, that's the nice thing about the Proj reprojector, and I don't want to sound biased or anything, but it is my favorite, and it offers so much flexibility. Like even in just the automatic mode, instead of picking a coordinate system from the list, you can actually just throw in a Proj string there. I mean, I wrote this complex web page to let you define a custom coordinate system for your CS map. In the Proj reprojector, you just have to drag and drop, or you just have to cut and paste the Proj string into it, and bingo, you're done. So it's 3 mode. You can pick off the list, you can drop the Proj string, or you can make an entire Proj script in there. So you can get really down into the nitty gritty of working with coordinate systems in the Proj reprojector. It's quite fantastic.
And Dave, where can you find those Proj strings? Is that the same as a Proj 4 string?
Yeah. It's a lot of people call them Proj 4 strings because Proj was at version 4 for a long time. I think they're up to Proj 9 now, but the strings are all the same. You can do what I do, which is really cut and paste from GIS Stack Overflow. A lot of the stuff you want, a lot of information you need is online. And chances are, whatever question you have, somebody's already asked it. Google is your friend. But you can write your own Proj strings as well. There's an online reference, a guide to that. And if you're doing Proj scripts as well, those are quite cool. And yeah, you generally, I have to go to the online reference all the time for that, to figure out the scripts. And like I said, GIS Stack Overflow as well.
Yeah, and I think our documentation should have links to some of those different resources as well. If you're ever unsure how to configure one of the reprojectors or find information such as the Proj strings, then I think that's the best place to go. And if you're already in FME, you can just click on the help button in the bottom left of the transformer and it should bring you straight to that page, which I find is a little bit easier than trying to Google for the documentation, because sometimes the Google search engine just doesn't pick it up. So that's a good tip there.
Yeah, actually, we had a good comment here from Howard on the U.S. state plane, and that, yeah, whereas the U.S. survey foot has been retired, a lot of users are still going to be using the old coordinate systems. So that's why in FME we never get rid of a coordinate system, even if they're deprecated. There's a little trick. The deprecated coordinate systems, for the CS map reprojector anyway, will not show up in the coordinate system gallery but their name can be typed in. And we do this because people have old workspaces that have used the old names, and our first commandment at SAFE is that the old workspaces should work. It doesn't matter if you wrote them 20 years ago, we want them to work. We never get rid of a coordinate system, so if you have your old favorites that you use and that may be deprecated, they're still there.
Awesome. All right, it looks like we've gotten to most questions now, if not all. Any others that we can address live today? And a note that if you do have a question that comes up after the webinar or a few minutes after we end, I'll just keep the webinar running a few more minutes. So we'll keep an eye on the questions tab if any other questions come in.
I was just going to look back at one of the other questions we had from Ben Patterson. I gave a bit of a short answer about how the Esri reprojector differs from the other reprojectors. A couple things there is that you can specify the geographic transformation. For a lot of users, it's just because they're working with Esri already and they want to make sure that they're seeing the same reprojections that they see in ArcGIS Pro or whatever software they're working with. And then also there's support for vertical reprojection. So I'm not sure, Dave, if any of the other ones support vertical reprojections.
CSMAP does. Esri reprojector does ship with more grid, although those grids are usable, like they're in FME and they're usable with the CSMAP reprojector as well if you want. The difference between the two, and is the difference between Proj as well. Like I said, I like Proj and I find it's the most versatile, but CSMAP is by far at present the fastest reprojector by a factor of, like, it can be 10 times as fast as the Esri reprojector or the Proj reprojector. So if you're doing a massive amount of data, CSMAP might be your best first stop.
Yeah, Nell had a great comment there about the reprojector and if it's the same as Proj. So just, it's a little bit, I guess, implied or hidden, but the reprojector uses CSMAP reprojection engine, and then the Proj reprojector uses Proj. And of course, there's also CSMAP reprojector. So it gets a little confusing, but just there's additional options there with the CSMAP reprojector.
Yeah, that's a history thing. We started off when we only had the CSMAP reprojection engine, we just called it the reprojector because there was no other choice. And that used the old CSMAP method of datum transformations where everything pivoted through WGS84. When CSMAP updated so you could have direct transformations, we added that to the new CSMAP reprojector. So the reprojector is kind of an easy one to start with. It doesn't ask you a lot of questions, but it just goes with the most common operation. The CSMAP reprojector gives you more control over your reprojection. That's basic. That's the basic ones. We might have folded in the reprojector into the CSMAP reprojector, but again, we're really big on the whole backwards compatibility thing. So.
All right. Any other questions we want to address before we wrap up here?
I think that's good. Yeah, I think we answered most of the questions there.
Awesome. Yeah, and if we didn't get to your question, we'll be sure to follow up via email as well. So feel free, if you do have a question that comes to mind in the next couple minutes, feel free to drop it in. We'll be sure to get to that.
I'd say for the question on the British wartime Cassini grids, that's going to require a little bit more research. So if you want to drop us a line in support or even on the community, we can answer that through there.
Awesome. All right. And with that, I will note, if you do have a moment to fill out our webinar survey, we really appreciate any feedback. I believe it's just actually one multiple choice question that's mandatory. So yeah, we appreciate it if you have a moment. And a huge thank you to our whole team for presenting and supporting with Q&A here today. We appreciate your time preparing the material, and big thank you to our audience as well for joining us today. We appreciate your time. And we hope you all have a great rest of your day ahead or evening ahead. Thanks all.
Yeah, thanks
Bye
everyone.
for now.
Thanks.
Thanks. Bye-bye.
Bye.
Bye.